Hi everyone, welcome back to the workshop, and it's part 2 of the 3458A 8.5 digit multimeter repair. Now in the part 1 video, which I'll link down below, you saw me take care of most of the mechanical stuff, and I kind of identified that the A2 board here is looking like it's still faulty. I'd replaced a blown fuse and a transistor as a precaution, powered it back up, and we're still getting error codes on the front of the unit, albeit different error codes now, pointing to a further problem on this board by the looks of it. Not necessarily, but at the moment it's looking like the A2 board here, the AC board, still is a problem. Now, the fuse didn't blow for no reason whatsoever. Something caused it to blow. And so what I'd like to do, I've got the new fuse fitted and it's powering up fine and it's not blown again. But I would like to know what sort of current is going through that fuse. Now I know the resistance of it because I measured it before I put it in. And if I measure the voltage across it, I should be able to work out what the current is through that fuse. Right, let's just measure it carefully. About 80 millivolts. Well, that works out at about 34 milliamps going through that fuse. It's a 125 milliamp fuse, so it's well within the limits of it. So I don't think there's a problem on that rail anymore. Not unless there's something intermittent. And going by what I've seen online, other people have measured about the same 34 milliamps going through that fuse, because it has been prone to blow on some other AC boards repaired by other people that I've seen. So anyway, let's get the thermal camera out now and let's look for anything out of the ordinary, because there are other power rails coming into this board that may be causing problems. Right, so I'll just scan around the board. Let's just see what we can find. Well, there's a couple of regulators there. That is the regulators in question that we showed earlier in the schematic. They're about 50 degrees. Not too bad. And there's one device down here which is a little bit warm. It's about 52 degrees, and that's actually designed to get warm. It's got pins on it that are designed to be used as heat sinks. So I don't think there's a problem there. And there's a resistor down here, a 10k resistor. It's got about 9 volts across it. And that's just a few milliamps as well, so not really a problem. So I'm not really seeing anything jumping out at me at being super hot. I think the hottest is maybe about 53, 54 degrees there. Future Ian here. Now I'm waiting on parts coming for that AC board, but in the meantime I did film quite a lot of other bits and pieces on the 3458A, and that's what's presented here. So you won't see the AC board repair in this video, but there's quite a lot else. Enjoy. Now, one thing I was curious of is when I power up the unit, the display is blank. I'm not getting any conversions. And so I thought I'd take a look at that. Now, there is actually a command that you use, trigger arm, T-A-R-M. I'm used to using that via GPIB to initiate a conversion. And I just wonder if TARM has been shut down due to the error we're getting, just as a precaution, so that the 3458A is basically telling the user we've got a problem. But I can turn TARM on, I can reset that trigger. So if we go to TARM and I'll set it to auto, and look at that, it's working. I am getting something on the display now. Wow. Of course, if I reset the 3458A, it does exactly the same. It just blank display, and I've got to manually enable TARM. But now we've got an opportunity to actually test the AC board, because we can just go to AC there, input some voltages and see what happens. Now I've actually gone ahead and done that already, and I went through all the different ranges, auto and the manual ranges, and I input an AC signal and they were all accurate. Every single range had the right voltage displayed on it. So the analog path is working. It looks like that error is just stopping the actual triggering from running. Since we've got it working, I'm actually going to hook up a PDVS-2 Mini and run it for a while. I'd like to know whether the A3 board is drifty or not, and that's very easy to do. Leave the meter running for most of the day. I'll hook it up to my PDVS-2 Mini, set to 1 volt, and we'll see what we get. So I'm on DC mode right now, PDVS-2 Mini set to 1 volt. So let me just plug in there. Now as you can see, I'm getting 1 volt, so DCV mode's accurate enough as well. I'll just set the number of digits to the maximum. There we go. And I'll leave it for a while. I'll make a note of that voltage there. I could log it by GPIB, but we'll just see how it goes over the next few hours. Leave it running and we'll see what we get. Well, actually I did go ahead and connect via GPIB and log the data with WinGPIB, and I'll pop up on screen a screenshot in the playback chart of the results that I found. Now as you'll see, there is no real apparent drift, because if there had been a U188 drift problem with that A3 board, you would either seen a gradual climb or a gradual decline of the logged data, but we certainly weren't getting that. Now it looks quite noisy on the graph, but in actual fact it's not too bad, because the maximum to minimum voltage that you're seeing there is only 10 microvolts, and that's across a just under 4-hour time period. Now given also that I'd only powered up this meter for about an hour before starting the log, I've got no idea how long the unit had been switched off in the weeks, months, years beforehand. So the results are actually very good. So I can put aside any drift issues that the A3 board may have had. Now the next thing I want to do before I get back into the A2 board, I do actually want to upgrade the firmware in this unit, because I notice it's running version 7.2, which is quite old. So this particular CPU board has the single ROM in it. Some of them have got a bank of 6 ROMs. This is the Rev B board, so it's got the single ROM. And I've gone ahead and programmed up a new V9 version of the firmware, a socket to put on the board. So I'm actually going to go ahead and do that now. And there's the board removed. It's a really nice board, front and back. And the date code I mentioned in the part 1 video, they're a mix of 94 and 1995, but you can also see there's actually a little handwritten date there, 24th of February 1995, so that confirms it. This is a 1995 machine. Now I could do the Dallas Rams and convert them to FRAM while I've got it out, but I'm actually going to leave that for another day. This board's dead quick and dead easy to take out. I'm just more interested in the firmware at this point in time. So there's the EEPROM there, U110. I just need to put a socket in there and put my new firmware, my version 9, in its place. Well, as you'll have seen, I'd use my old solder sucker. It's good to keep your hand in every now and then using these old tools. As you can see, it's perfectly removed. and I haven't pulled out any of the through-hole plating on the board. Perfect. So I'll give it a clean up and put in the new socket. There we go, let's clean up the board. So there's the new EEPROM fitted in its socket. Put it back in the unit and power it up. Okay, here we go, ready for a power up. And yes, it's working. And I'll check the rev number of the firmware. It was 7.2. So R, and go down to rev. There we go. 9.2. Oh, I thought there was a new one, 9.4. Maybe I put the wrong one on that EEPROM, but there'll be very little difference between 9.2 and 9.4. This'll do me. Well, here's a nice wee quirk of the AC board error. So I've just powered up, I've cleared the errors, and as you'll remember, nothing on the display. But I can jump start that by setting TARM to auto, and you get some readouts. But not is all what it seems. Now, though it's accurate in all the modes, you set the NPLC 0.02, it's not particularly fast. I'm getting about 1 a second. Really curious. Now if I change the number of readings to say 5, you can see it does 5 individual acquisitions there from the A to D board, but then you get this great big pause, a delay of about a second between samples. So that AC board error looks like it's causing an extra software glitch. Not totally unexpected because there is a fault with the meter, but just curious about that. And this came to light when I was doing a GPIB download of the calibration data. It was quite slow to do so, and I didn't really notice at the time. So anyway, hopefully when I get the AC board fixed, this will all return to normal. Well, I thought I'd replace the Dallas non-volatile RAMs. These are the original ones fitted when the board was made because they're dated 1994. So I'm going to replace them with FRAMs. And that should see out this 3458A's lifetime because there's no batteries involved. But I just thought I'd recap on the various different options that are available to the 3458A. So for the Cal RAM, there's a couple of different options available. There is the DIP version, the FM1608 version of the FRAM IC. And what I've got here is an adapter board that I've produced that basically you put an IC socket on it and plug the RAM into there. And then with a couple of rows of headers there, it adapts down to emulate the original Dallas RAM. And you can program this in your EEPROM programmer before you fit it to this board. Now the other option is to use the surface mount version of this IC. And via this little adapter board that I've produced, it adapts the FRAM pinout down to the original Dallas pinout. Now they're not one-to-one pins. There are some pins on this IC that are tied low, and some of the pins are moved around in order to make it compatible with the Dallas RAM. Now there's two options for programming this FRAM IC, and that is do it before you solder it to this board. Or you can use this adapter board that I've produced, basically plug that into there, and this unit here adapts the pinout back to the original FRAM pinout. And then what you must do is when you program this in your programmer, you must set the upper end to 7FF, not the original 1FFF. Otherwise, it'll fail. Now, some people have said that this adapter board doesn't work in their programmer. All I can say is it does work in the Dataman series of programmers. And are you absolutely sure you're setting the upper end to 7FF? For the settings RAMs, it's a lot easier. all you need to do is go into Amazon or eBay and buy a SOP28 to DIP28 adapter. They're just 1-to-1 pinouts, and basically you can solder this directly onto the board, and that's it. And of course you'll need two of them, one for the upper bank and one for the lower bank. The other option is to use the DIP version of that surface mount IC, and I've got them already made up here and already programmed with my settings data, and all you need is a couple of IC sockets and off you go. So for my 3458A, I'm going to go ahead and use the DIP versions of both types of FRAM. Okay, I've got the new FRAMs installed, the new settings RAMs and the calibration RAM. So let's power it up. And I'll just reset the usual errors. And I'll do a term. Auto. I've got a readout. And I've got PDVS2 Mini set to 1 volt. And if it's working, I should get 1 volt on the display. And yes! Perfect. So that's the cal RAM verified. But what about the settings RAMs? Well, like I've mentioned earlier, the cal RAM data that I've programmed to these two chips came from my original 3458A. And I had set some of these keys, the function keys, as secondary functions. And I think I remember one of them, F0, was temperature ? To have a look at the internal temperature of the 3458A. So, shift. Yes! It's working. Now I can't remember the other ones. Let's just have a wee check here. F1. ACAL DCV, yes. So the settings RAMs are working as well. Perfect. Okay, so the next thing I want to look at is replacing this IEC line filter. You can see it's a bit dark looking. Looks like it's maybe been getting a little hot, and in fact, I know you can't see it, but there's a little bit of a bulge going on there. And there is actually REFA capacitors inside these units, I believe. And they have a tendency to explode. So this little bulge here is, I think, it on its way out. So I'd rather change this filter sooner rather than later. Now I've got a replacement, and I was pointed towards this one specifically because the plastic outline here apparently fits the 3458A opening on the back there without actually filing down that plastic a little bit in order to make it fit. I'm not so sure because it does look kind of like the normal size, but we'll see once we get this one out and whether this one fits in its place. And as you'll see, the existing filter is actually pop riveted in, so I'll have to drill them out in order to get it free. Well, there's the old one out and the new one. And actually, I think it does have a slim outline there, the plastic outline there. It might just go straight in. So I'll see how I get on. And there it is. It does fit in perfectly. No filing required in that line filter. And it's a shorter 4300.5054. Now you might have noticed there is a REFA capacitor down there. A 2.2 nanofarad Y-class. I'll get to that one eventually when I get this board out in the future. But for now, that's the line filter installed. Well, couldn't resist it, so I took the old filter apart. What a mess. You can see there's a plastic former there. We've got a circuit board there. And look, there's the inductor there. But if I turn it over, looks like we've got a capacitor here. And I think there's two capacitors, one there and one there. And those two are kind of like the same colour as the REFA capacitors. So I wonder if it's those ones that go bang. This one here, not too sure what that one is. It looks like a capacitor as well. You can see the legs on either side there. Not too sure. Maybe it's that one that goes bang.